and today we're going to look at Taylor series, and I have a question that I was asked by one of my viewers and one of my audience, and the question says that we expand a function. Just a minute. So the question says that expand 1 plus x plus x cubed in a Taylor series about the point x equals to -2. Then Roman 2, it says hence evaluate the integral. This is integral from 0 to -1 of 1 plus x square plus x cubed divided by into bracket x plus 2 to the power of 2, and with respect to dx, and both the two question is 10. So we can now look at a solution on how to approach this. First, you have to note that Taylor series as a center. Taylor series as a center, and in this case, our Taylor series is centered at -2. So -2 is the center of this Taylor series. And again, we know that in Taylor series, that f of x is equivalent to, f of x is equivalent to f of a plus f prime of a, you divide by 1 factorial into x minus a to the power of 1 plus f double prime of a divided by 2 factorial of x minus a squared plus f triple prime of a divided by 3 factorial of x minus a cubed, so this is cubed, plus dot, and therefore from what we have here, we have our f of x equals to 1 plus, that is 1 plus x square plus x cubed, and we know that f at -2 This is given by 1 plus minus 2 square plus minus 2 cubed, and this is equivalent to negative 3. Then f prime of x, now we differentiate this. So the derivative of 1 with respect to x is 0. We differentiate this to give 2x plus 3x square. Then f prime at negative 2, this is 2 into negative 2 plus 3 into negative 2 squared, and this one will give positive 8, because this is 4, this is minus 4 plus 3 times minus 4. Sorry, this is 4, so this is 3 times 4 to get 12, so minus 4 plus 12 is positive 8. Then double prime of x, we differentiate this with respect to x, and this will give 2 plus 6x. Then double prime of that function at 2, or when evaluated at negative 2, the second derivative evaluated at negative 2, this gives 2 plus 6 into 2. This one will give, so this is negative 2, so this is minus 12 plus 2 to get minus 10. Then we have our third derivative with respect to x. We differentiate this with respect to x, and this one will give 6. It will give 6. Then from there we evaluated that derivative, the third derivative at negative 2, and this one gives 6. So from there our fourth derivative with respect to x gives 0. Then we evaluate it for the derivative at negative 2, we get a 0. So from there you can simply say that our expansion now becomes f of x equals to 1 plus x squared plus x cubed is equivalent to minus 3 divided by 0 factorial of x. Now if you look at our function here, it is x minus the center, and the center is negative 2, so this is plus 2 power 0 plus 8 divided by 1 factorial into x minus minus 2 becomes plus 2 power 1. Then we go to our third the third value, which is negative 10, and this is negative 10, so this is negative 10 divided by 2 factorial into x minus minus 2 plus positive 2 squared plus 6 divided by 3 factorial into x minus minus 2, that is plus 2 cubed plus dot dot dot. The series is continuous, so this is the same as saying minus 3. If we compress this down, so this will be minus 3 plus 8 into x plus 2 minus, this is 2 factorial, this will give 5 into x plus 2 everything squared plus 3 factorial gives, so 3 factorial is equivalent to saying, so 3 factorial is equivalent to say 3 times 2 times 1, which gives 6. So this is 6 divided by 6 to get 1. So you're left with into bracket x plus 2 cubed plus dot dot dot. So we may leave our answer at this point. We may leave our answer at this point for the first part, that is Roman 1. But if need be, we may consider expanding and collecting the like terms together. So this is minus 3 plus 8x plus 16 minus 5x square minus 20x minus 20 plus 2x cubed plus 12x square plus 24x plus 16. So if we collect the like terms, this becomes 2x square cubed, 2x cubed plus 7x square plus 12x plus 9. So again, this is correct. This is correct, but I do urge for the cases of the second part, you let it at this point. You stop it at that point. Then for part 2, that says that we evaluate the integral from 0 to -1 of 1 plus x squared plus x cubed. You divide by into x plus 2, everything squared with respect to dx. Now for this part, this is what is expected. So this is Roman 2. For Roman 2, this is what is expected, that we need to do some substitution. So we substitute, we say that this is integral from 0 to -1 of 1 plus x squared plus x cubed. You divide by into bracket x plus 2 square with respect to dx. So this is the same as saying integral from 0 to -1. Then we substitute the value that I said we may leave our answer at that point, and that value was -3 plus 8 into x plus 2 minus 5 into x plus 2 squared plus into bracket x plus 2 cubed. Then we divide everything by, this is x plus 2 square with respect to the x. So from this is simply interpreted as integral from 0 to -1. Then we treat each term independently. So this becomes -3 divided by x plus 2. Then squared, we add 8 into x plus 2, we divide by x plus 2 squared minus 5 into x plus 2 squared, we divide by x plus 2 squared plus x plus 2 cubed divided by into x plus 2 squared with respect to the x. So from there we simplify the expression. And upon simplification, we'll get separate terms. So we will get separate terms, and we integrate each term. So this will give, if we simplify, we will get from 0 to -1, that is integral from 0 to -1 into -3 divided by x plus 2 squared plus 8 into x plus 2 minus, so you realize this one will cancel with this, then this one will cancel with this, so this is -5 plus this one will cancel with this, so you will remain with x plus 2 dx. So one of will be number 1 on the first integral. We'll have a integral from 0 to -1 of -3 divided by into bracket x plus 2 squared with respect to dx. So this one will be our first integral. Then our second integral will be integral from 0 to -1 of 8 you divide by so this will be our second integral. Then we'll have a third integral, again integral from 0 to -1 of -5 with respect to the x. So this is our third integral. Then fourth integral will be integral from 0 to -1 of x into x plus 2 with respect to dx. This will be our fourth integral. So from there, it simply implies that we integrate each term independently, and then at the end we combine the solution of each integral to get our final answer. So we start with the first integral. So first integral, we have integral from 0 to -1 of -3 divided by into bracket x plus 2 squared with respect to the x. So from there we can use the u substitution. So by u substitution, by u substitution method, we say let u equals to, x plus 2, and therefore du equals to dx. So when x equals to 0, u equals to 2. So that is, now we are working on the boundary. When x equals to 0, u equals to 2, and when x equals to negative 1, u equals to positive 1. Therefore, the integral becomes, so this is integral from 2 to positive 1, of minus 3 divided by u square with respect to du. And in other words, this is like saying minus 3, you pull the constant outside, so minus 3 integral from 2 to 1 of u to the power of negative 2 with respect to du. So this is, let's say, if we integrate this is equivalent to minus 3 into minus 1 over u, cross the bracket, then you input your limit. This was 2 to 1. So therefore this implies that this is minus 3 1 over 1. We start with the upper limit, minus, this becomes minus, which is positive half. So if we evaluate this, we will simply get that this is equivalent to minus 3 into minus 1 plus half, which is equivalent to minus 3 into minus half, and minus 3 multiplied by minus half, this is 3 over 2. So the solution of the first integral of the first part is 3 over 2. Then we continue with the second part. That is a second integral. So the second integral, we have a integral from 0 to negative 1 of 8 divided by x plus 2 with respect to dx. And again, by substitution method, we can say let u equals to x plus 2, and therefore du equals to dx. So again, we work on the limit of the integral, and this is to say when x equals to 0, u equals to, when x equals to 0 from this part, u, so you replace x with this one, you remain that u equals to positive 2. And when x equals to negative 1, again we find that u equals to positive 1. So from there we integrate, and now our limits will be integral from 2 to 1 of 8 you divide by u with respect to du, and this is to say this is 8 integral from 2 to 1 of u to the power of negative 1 du, and this will give 8. Then the integral, this integral becomes, so this is equivalent to 1 over u, and from the SMP table, the integral of 1 over u, just a minute, from this table, from this SMP table, the integral of so this integral at this point, this is the integral page, so I'm referring to this 1 over x, so in our case it's 1 over u, it's the natural log of x, so in our case it will be the natural log of u, and again there are some specific conditions that must be met. So from that you can simply say that this is 8 natural log of u, and we fix our boundaries, it is 2 to from positive 2 to 1, and this you can simply say that this is 8 into the ln of 1 minus ln of 2, and from the calculator we can find the two natural logs. By simply saying that the ln, that is natural log of 1, the natural log of 1 will give us 0. So this is to say 8 into 0 minus natural log of 2, and we can simply say that this is equivalent to minus 8 ln of 2, that is natural log of 2, and our third integral, our third integral, we have to integrate from 0 to negative 1 of 5. So this is negative 5 with respect to dx. So this one is a direct, this is very direct, it's a direct integral. So we can simply, this is equivalent to minus 5 into x, then you put your limit from 0 to negative 1, and this is minus 5 into minus 5 into minus 1 minus 0, and this gives minus 5 into minus 1, which is equivalent to positive 5. So fourth integral, our fourth integral is we integrating from 0 to -1 of x plus 2 with respect to the x. So you can simply break this into two and say that this is the integral from 0 to -1, sorry, of x with respect to the x plus the integral from 0 to -1 of 2 with respect to the x. So if we deal with the first part, we integrate. So this becomes x squared, you divide by 2. Then you insert your limit, which is 0 to -1, plus, come to the second part, the integral of a constant value with respect to x. It is that value multiplied by the variable x. So this is 2x. Again, you introduce the limit, which is 0 to -1. So if we simplify this, the first part here will be -1 squared divided by 2 minus into 0 divided by 2, then you subtract into bracket 2 into -1 minus 0, 2 into -1 minus 0. Then we have so the very first part, this becomes positive half minus, this is automatically a 0. So in this column, in this bracket, we remain with minus half. Then on the other side, we remain with minus, this will be minus 2 divided by 1. So it's a constant. To make it half, we divide the 2 with 1, and therefore the LCM is 2. That will be 1. This will be 1 minus, this is 2 multiplied by 2 here, we get 4. So this is equivalent to -3 divided by half. So -3 divided by half. And if we combine our integral now, the solutions, if we combine all those solutions, you realize that we are integrating, our initial integral was from 0 to -1 of -3 into x plus 2 squared plus 8 divided by x plus 2 minus 5 plus x plus 2 with respect to the x. So this is the first part. We obtained the integral as 3/2 minus 8 natural log of 2 plus 5 minus 3/2. So we simplify this one and this one will cancel. So we are left with minus 8 ln of 2 plus 5. So we can simply say that this is equivalent to positive 5 minus the natural log of 2. Sorry, this is sorry, this is 5 minus 8 natural log of 2. That is our solution. So to my viewers, kindly follow, listen to understand, follow the steps, and listen for understanding. In case there's any query, free to raise it on the comment section, and kindly feel free to comment and give suggestions on the topics that you'd like me to cover. You suggest the topics, the areas, and if there's any question, I will share a group link, that is our WhatsApp group link, under the comment section. Join the group, ask the question, and again remember to share with a friend, tell a friend to tell a friend. Let's learn together, let's advance, let's eliminate poor performance in mathematics. So let's be brightened and have a well understanding. Thank you. And this was a question that came in one of the national examinations, and the question carried 10 marks. So I've tackled part B. I will tackle part A in my next video. I'll be tackling part A. So the question was a Taylor series question, which was to expand the Taylor series. Then after the expansion, we solved the integral part of it. So thank you very much for supporting my YouTube channel. Thank you for your consistency. May God bless you. Bye bye.